All right, so the next thing we're going to do here is we are going to do properties of exponents. So when I'm looking at this, uh, in this equation, you will generalize the expression definitions, determine the value of this. So I'm going to say my answer is 1. Um, so I know the answer is 1, but I have to express it. So the first thing that I would recommend doing is going into the equation editor, and we're going to write down log sub. So this is how we're going to do the subscripts here. Sub b of b is equal to b to the x is equal to b. Or I should say, I shouldn't say equal to. This is the same thing as, I'm going to put a little arrow here. Same thing as, I'm going to kind of ignore this part, or I can write this. Same as, so this is the same as this. Um, since b to the 1 equals b, x equals 1. So this explains my reasoning because I'm saying like this. So I'm saying since log base b is the same thing as b to the x equals b, uh, and I should say this is and b to the 1 is equal to b, then x equals 1. So that's how I came up with my answer of 1. I'm kind of just rewriting what log is in order to come up with 1. So the next one, I'm going to use properties of exponents to determine what this is. So I'm going to say, since log sub b of 1 is same. You guys don't have to draw this arrow. So I'm just kind of using math symbols to kind of do this. Same as uh, b to the power of x is equal to 1. So you guys can do this in words, but the thing is you have to explain what you're doing here. All right. And b to the 0 power. Basically what I'm saying here is this b represents any number, and b to the 0 power equals 1, then x has to equal 0. So what I'm saying here is log of any number to 1, log of any number. So this question right here is asking what power of any number will give us 1 as our answer. So instead of writing it like that, I can say it as any number to the x power equals 1. Well, any number to the 0 power is 1. Therefore, x, which is our power, has to be 0. So log base b of 1 is 0. So explain how you did here. This one, feel free to grade yourself a little like hard if you don't understand it. Again, we're not grading you based on how you think, uh, based on what you know now. That's what the tests are for. This is a time to just reflect and really ask yourself, do I understand how to rewrite this? That's why I said at the end of the last video, like, yes, I didn't do that much practice, but really understand how to write this down. If you had trouble understanding how to rewrite this, it becomes harder to understand how to do this. Understanding this second part where I put all the ands, that's a different issue that we're going to practice a little more on. So here we're going to write about common logarithm. So the common logarithm is base 10. So that's what we're always talking about. When we're talking about the common log, we're talking about log base 10. And that's kind of what I briefed on a little bit earlier in the first video, is that anytime you see a log with no base, we're talking about base 10. This is useful when rewriting other logs. So it's a button on the calculator. So if you don't understand what's going on here, just know that it's a button on the calculator. So that's why we use it a lot. Find this log. So what we're doing here is we're using the product property. Remember I said that if you're multiplying two things together, what you can do is you can split it up into two different logs. So because this is being multiplied, you can split it up into two logs that are being added. All right, so the next thing we're going to do is for logarithms with base other than 10, what we're going to do here is we're going to split this up into two different products. So we can just say that this is equal to x. All right, then we can then say that 2 to the x power is equal to 63. All right, I mean, yeah, that's kind of weird, but okay. So then we can also say that log of 2, so we can say like, oh, wait, why don't we just do this? Log base 10 of 2 um, is log base 10 of 2 to the x is equal to log base 10 of 6. Or as you see it in the calculator, log 2 to the x is equal to log this. Well, from that point, what we can do is we can divide it. So this is where I said that thing where if you ever see a log like this, you can rewrite it as log of the big number over log of the little number. So this being the case, it allows us to type it into our calculator. So this equation is equal to that. And then we can just plug that into our thing so much easier, or into our calculator so much easier. All right. So moving on to the next one, we're going to do the change of base allows us to write any logarithms as a logarithm. So what this says is we can just change anything. It doesn't just have to be log base 10. We can do by anything. And they're showing it here with the log base 10. So they're like, why not, instead of using log base 5 like we're doing here, why don't we just call it log base 10? So we can just do it. Again, this is something I already showed you guys. They're just saying like, hey, this makes it so much easier to just plug into a calculator. All right, so we're going to use this new rule into solving the rest of them. So let's say we have this equation right here. All right, so this is kind of hard to do, but using our knowledge, we're going to do log 216 over log 6. So I'm going to hop over to my Desmos calculator here. Logging on here. I'm going to get rid of this. 216. I am going to do a division sign here, and I'm going to put log. I was going to do something else, but I'm like, I might end up deleting it. So I just did the division afterwards. And I end up getting this 3. So that tells me that 3 times 3, or 3 times 3, 6 times 6 times 6 should equal 216. Let's double check that real quick. 6 times 6 again, 216. Wow, it works. So here, oops, sorry, I was doing work with another student. Let me close all this and go back. There we go. That way Desmos is right where it needs to be. All right, so this is gonna be 3, which I'm sure you guys saw before I cleared it to unanswered. But again, this is about learning how to do it, not just getting the answer. So let's go back to unanswered. All right, so we have this long, complicated thing, and essentially what we have to do here is solve all of these. Well, all of these are base 3. Well, base 3 means we can multiply it. So what I'm going to do here is I'm going to say, well, this is the same thing as log 3 to the, let's find out what 9 times 27 is. 7. This is going to be log base 3 of, who knows? Let's find out. 3 times of 3, 9. Clear that out. Here. 9 times 27. So we get 253 or 243. Okay, so we got 243. So 243. So now I'm going to figure this out in a calculator. So the easiest way to do this, let's say I had a regular calculator like this, you'll notice that there's still a log button. So even if you don't have Desmos, there's still a log button we can use here. So I'm going to say log. Oops. Oh, I remember why I don't like these calculators. You want a calculator that writes it all out for you. So I'm going to say, I'm going to start this from the beginning. Log of 243. So I'm going to say log of 243. Be careful with Desmos because it likes going all the way to the right if you go to another tab. Watch. Let me show you. So let's say you see how it's inside the parentheses right now? If I go to another tab and go back, it's outside the parentheses. So just be careful with that. It likes moving your cursor all the way to the right. Divided by log of 3. It may not seem like a big deal because I wanted to go to the other side of the parentheses now, but if you're doing a square root and you forget what's in the square root, it does become a problem. So that one I got 5. So I'm going to put this, I'm going to put a 5 right there. All right, so I'm going to do the rest in a different color now just to kind of keep things different. I'll do it in orange. So this one, I'm going to write this down as log base 2 of 8 divided by 4. Because remember, the subtraction on this one means that we're dividing. So this is the same thing as log base 2 of 2. Because 8 divided by 4 is 2. Oh, well, that's easy. That's just a 1. I didn't even have to use a calculator to solve that one. Well, let's say we did. Let's say you're like, I don't know, Victor. Sometimes you make mistakes. Uh, let's show you guys right here. Boom, we got a 1. Awesome. So this one's actually really interesting because what's happening here is we have a bunch of things going on. Well, the first thing I want you guys to realize is like, oh, I don't like that exponent right there. Um, it's kind of weird. And also, I have this 5 here. So let's kind of focus on this a little differently. Let's think of it this way. Log base 5, it's supposed to be a 5, 5 to the 1 times 5 to the 1/3. Oh, wait. I can just add these two together. Kind of. We have to use our idea of fractions here. So I have to say log of base 5 of 5 to the 3 over 3 times 5 to the 1 over 3. Okay, cool. So what I can do here is I can be like, okay, so this is uh log 5, 5 to the 4 over 3. And you know what? I skipped a step there. I'm sorry. This is the same thing as log 3 over 3 plus 1 over 3. So I couldn't add these exponents before. So let me give you guys a chance to soak this in before I show you how I should have shown this. I should have done this as, so take that in. If that doesn't make sense, let me show you what's happening. These two are the same base and they're exponents. So that means I can rewrite it as log base 5, 5, 1 plus 1/3. So because of the law of exponents, I can add them. Well, guess what? I don't know how to add 1/3 to 1 to this is a whole number 1. So I have to rewrite it as log of 5, 3 over 3 plus 1 over 3. So that's how I got to this point right here is 1 is the same thing as 3 divided by 3. So this lets me add them together. So now I end up getting this. Let's go over here. Now I end up getting this log 5, 5 to the 4 over 3. Well, there's actually a pretty cool property. Remember with the exponent, I can take this exponent, move it to the front. So, oh my gosh, we keep going everywhere here. I'm going to take this idea here and rewrite it as 4 over 3 times log 5, 5. Well, I already know log 5, 5 is a giant 1 because it's saying 5 to the x is equal to 5. And we already kind of did this except with b's in the last one. So um, I'm sorry if this is like going everywhere. I feel like they went 2 is the easiest from this. 3 is clearly the hardest. And 1, I'm like, yeah, that took a little bit. So you kind of have to use a lot of properties here. This is the way I recommend doing it. We want to combine these two. You can't really see them as exponents, so that's why I wrote them as exponents. And then exponents with the same base, you can add them together. Once you add them together, you can see like, oh, this is just a giant exponent. Let me do some erasing here. So, oh, that's not an eraser. There we go. So these two added together gives you the 4 over 3. The next step there is you can take that exponent and put it in the front. Well, log base 5 of log base 5, that's just a giant 1. So you have 4/3 times 1. So our answer is 4/3. I feel like they got really complex there really quickly, but hopefully we'll have some practice where you can see how to do that. So let's see how they explain it to see their perspective on it. So they did the same thing I did. They're like, oh, well, this is 1 and 1. Actually, they did theirs a little bit smarter than mine. I can admit when theirs is smarter. What they did here was they're like, oh, you're multiplying here, just turn it into addition. That actually was a more productive way to do it, Edmentum. I normally don't give you guys credit, but that is an easier way to explain this. After that, what they did was they used their power rule here to move this to the front. And then they're like, well, this is just a 1, and this is just a 1. So 1 and then 1/3 times 1. Okay, that makes this easy. They use this ability here to say the log of b argument b is equal to 1. So they're like 1/3 times 1. So what they're not showing here is the step where you get 1 plus 1/3 times 1. But I don't think that's really necessary. And they get this. From there, they changed it to 3 over 3 plus 1 over 3. So I actually like this method better, how they did this. So just remember, this is a product property that lets us do that. All right, so going on to, oops. Well, hopefully you guys would see this. Oh, this is actually really easy. So if you guys saw the answers, like that's fine. All these are literally just plugging it into the calculator, which I can actually do with my simpler calculator. I don't like using these simple calculators. Um, Mainly because they're simple. This one, you literally have to type in 300 before you hit log. I already hate that. Um, and they want us to do how many decimal places? 2 decimal places. So if you look here, I only want the 47, but I have to look at this 7 right here to see if I round up. It's 5 or bigger, so I round up. So that's 2.48. I'm going to do log of 3.2. And again, this simple calculator, I hate it. I have to type the number in first, then I have to type in log. So 2 decimal places, I have to do this 51. This 3 is not 5 or bigger. So I'm going to put 0.53. Oh my gosh, what is happening here? I don't know what's going on right now. Let me unplug my. Okay, something weird was happening there. Oh, apparently, the cable of my headphones is the same material as my pen, or I don't know what's going on. Let me pause real quick and see if I can figure this out. Well, I'm not sure what exactly was going on, but hopefully we fixed it. So let's go back here. I'm going to clear this out. And 3.26. Oh, shoot. Log of 3.26. I really hate this because most calculators let you type it in afterwards. So that's 51. This 3 is not bigger, so I'm going to put 0.51. I'm going to do log of this. Well, this one's kind of interesting because this one you can actually solve by hand. It's actually going to be 4, and the reason being it's 10 to the x power is equal to 10,000. So the cool part about base 10, this is why we use base 10 a lot, is, you know what? I haven't plugged in my headphones, so sorry if I sound different. Let me plug this in. I'm not sure how that's going to affect the audio. I'm sorry. So when you do 10, 10 times itself, if you do 2, you have 2 zeros. So in this case, every 0 is a power of 10. So in this case, you have 4 zeros, so your answer should be 4. So I'm going to plug in a 4. And then 20 base 10. A lot of people think this is 2 because 2 times 10 is 20. It's actually not. It's actually very different. So let me do this on the calculator just to prove it. So we're going to do 20 log base 10. It's 1.3 because it's 30. That 1 is not going to change to 30. So I get 1.30. Cool. So like I said, I don't really like using simple calculators like that where you have know your calculator. Calculators are stupid. You have to learn how to use them because they all operate differently. This one I had to do log. I had to type in 3 and then I could do the log. Uh, Desmos, which I think is a better calculator, you can do log, type in the 3 in parentheses and do it. It's a lot more specific. So it just depends on your style. I prefer Desmos. You can type more stuff into it. I just think it's more useful. All right, so let's take a look at these. So we need to see which statements are true. So remember, we have to rewrite these in a way. I do not recommend using a simple calculator for this. You're going to have to use an actual scientific calculator. This calls itself a scientific calculator because it can do functions like a scientific calculator, which is cool. Like it's cool that you can use those functions. But if you want to do more step by step things, Desmos actually lets you do a lot more. So we're going to do log of a 101. So log 101 divided by log. And what I like about Desmos is you can see it the way the calculator calculates it out. Log 4. Oops. There we go. See what I mean by if you go to another tab, it kind of messes you up. All right, 4. So I get 3.29, 3.329. That's about right. And then 71 and 2. So I'm going to do log of 71 over log 2. So I get 6 point, about 15.149. So about 6.15. Yep, that looks right. And then 24 and 3. So I'm going to do log of 24. So I'm going to change this to a log of 24 over log of 3. And I get 2.98. This 2 doesn't change it. So 2.98. That could not be more different. I just double checked it right now. I was like, wait a minute. So that's wrong. So we're not going to check mark that. Then log base 5 of 66. So let's do log base 66 over 5. 6 over 5. 6 or 6, 2.63. 2.6. Yep, that's fine. That 3 will not change that 0. So 2.603 is more accurate. And then log base 6 of 11. So we're going to do 11 over log 6, and we get 1.33. Definitely not that. Nope. Uh, Double checking. Yep. So those should be our 3 answers. All right. So you can see the properties that they're doing here. This is just easier to enter into a calculator. They're doing the properties again here, but like I said, it's easy to just think log of the big number over the other number. Evaluate this. So just think about what you did. I would give myself like a harder grade on question 2, for example, just because of how uh, difficult some of this was. I didn't even, like I said, I didn't even think about doing the log base 5 of 5 plus log base 5 of 5 to the 1/3. That made this problem so much easier than how I was explaining it. So even I would give myself a low grade there for not thinking split up this product first. All right, so let's go to the next one. I'm hoping to get this done, but seeing as we're only halfway through, it looks like this is going to be a 3-parter, guys. I'm sorry. I'll try to make it a 2-parter, but unfortunately, time's not on our side sometimes. Exponential and logarithmic equations. All right. So the easiest way to find out a log or an exponent is it, like, how do we figure this out? The easiest way to do it is to just graph a straight line where y equals 400 and the other one is this. So we already did this in the warm-up exercise way back in video 1 for this tutorial. So we can see this here. I have no idea how. Oh, I see. They have very tiny increments right here. They're not even 1. Um, So another way of solving this would be using logs. We could divide this out and then use log base 10 to get rid of this power here, and that'll help us solve for x a lot easier. So let's get into that. So what we're going to do here is first things first. They're going to, I don't know why they're using log base 10 right away. I feel it's a little too soon for that. Oh, I see what they're doing. I mean, I guess. I honestly think they should have divided by 5.13 first, but they're like, yeah, let's do it this way. Then use the addition property to do it. Honestly, you should divide by 5.13 first. But this is approach 1. So I'm already telling you guys right now, I'm not going to teach approach 1 because I feel like doing this property where you add it right here is unnecessary. They used it good before, but in this case, it's not that great. And then we get this long, complicated thing. So I already don't like that. Log base 10 of 10 is 1, by the way. So that's how come you get this 2.3, but they're making this way too complicated, I feel. So if this confuses you, um, uh, it's honestly very weird to do, but you can read the steps. Let's see approach 2. I have a feeling approach 2 is significantly better. So they're saying like, hey, notice how this is the base 10. This is a base. This is the base of an exponent. Well, let's divide it out. Okay, cool. So this is the way I like doing it. So if you ever see an exponent, you can just be like, oh, you know what? Let's get rid of this a. If we remember from exponents, we usually write as our principal times our growth factor, and then our actual time it takes for that growth factor to happen. So it's saying like, hey, get rid of your principal, get rid of this 5.13 by dividing on both sides. Cool. This is the way I learned how to do it. And then from there, what we're going to do is we're going to take log base 10 of both sides. This is usually a number by this point. They're just making it look more complicated. And then you can just divide. But they're saying just plug this whole thing into calculator, which is honestly more accurate. It's more accurate to have this giant thing and plug into a calculator. Desmos, obviously, there's no way you can do this with the simple calculator. And just get the answer. It's a lot more accurate to solve, to move everything with X solved and just plug all of this in. All right, so let's compare. So, sorry. So doing it approach 1 gives you the exact same answer. Approach 2 and approach 1 gives you the same answer as graphing it. And if you want a better explanation of these steps, definitely watch this video. Again, I'm not going to do it here because it's just going to be weird for me to record my screen without me doing anything. I would literally just have this playing and staring at my watch until it's done because I know how to do all this, but the video's actually really good. And I don't want to repeat it when you can just watch it on your own. All right, so let's say we're doing this problem here. Well, if we're doing approach 2, I recommend doing approach 2. We're going to divide by 2. Even there, like, approach 2 is better. Do approach 2. And then what we're going to do here is we're going to do log base 10. So they're going to do, let's do log base 10. So they do log base 10 of both sides. And then you're going to divide it by 12 and log base 10. That way you're just stuck with this t. So that makes this easier. I think it's significantly easier. You could have divided by 12 first and then divided by log base 3. But because of the fact that you're doing this log anyways, it's like just divide by log 12 and log 3 at the same time. There's no sense in like doing step by step. All right. So another step of solving log functions is, let's say you have this function. If we're adding these two together, wait, what are we doing here? Oh, this is just identifying the variable in the expressions. So, because I was like, wait, how is this the same thing? It's kind of not. They're just talking about the variables and being careful of understanding what the argument is and where the variables are. So let's take a look at this one. So if we're solving this, they give you a word problem here to kind of see how it is. First thing we're going to do is assign the value. What are we solving for? All right, cool. So we have what we're solving for. Then what we're going to do is rewrite this as an exponent. So if this is log base 10, You don't see it, but we're assuming it's base 10. We're going to say this is equal to that. This 10 to the 1.67 power is equal to this 3 plus 2t. I'm really sorry I keep saying that, guys. I know some of you guys are auditory learners, so I'm trying to get better at it. 10 to the 1.67 power is equal to 3 plus 2t. All right. So from here, oh, wow, they did a lot of work. They're like, okay, let's subtract 3 from both sides. So first of all, they solved for 10 to the 1.67 power. They got 46.77. They used the calculator for that. So if you're like, how did they get that? They used the calculator to plug this part in. And they also switched these sides. So they switched the sides there are because they're like, well, we want t on the left, so we're going to have to switch sides. Then they subtracted 3 from both sides. Then they divided by 2. They showed their work later. It's very easy to subtract by 3 and then divide by 2. But if you do put this into calculator, make sure you have parentheses just in case. Desmos, you don't need parentheses because it shows you how it is. But if you're writing this on a standard scientific calculator, it looks kind of like this. Oh, shoot. Give me a second here. 46.77. Just know that that's not supposed to be a decimal. Oh my gosh. 46.77 divided or minus 3. Sorry. Ah. Minus 3 divided by 2. If you do not put the parentheses here, it's going to divide the 3 before it does the subtraction. So just be aware of that. I've seen a lot of people where they just don't know how their calculator works and it causes problems. All right, and then we have to always refer back to this. So remember, T was number of years after the year 2000. I kind of glimpsed at this in case you're like, what's going on here? T represented number of years after year 2000. So for the problem we were talking about, 2022 is whenever this money, the total spending would reach $1.67 billion. Honestly, this is kind of weird because the price of colleges and spending is a little different right now. But yeah, there's this formula here and how to solve it. So now let's talk about how to solve this type of problem. Well, what if we have a problem like this? Base 2. Well, another thing we can do is we can essentially say, why don't we raise this to the second power? What I don't like here is they didn't show, give me a second here. They didn't show the part where we said log base 2. They switched sides before they did this part. We're raising both sides to this 2. That cancels this part out. That's why we have 2 to the second equals 20 minus x. They kind of ignored the fact that we're raising it to the second power. So we're raising it this side 2, and the power is log base 2, 20 minus x. So this base 2 and this log kind of cancel each other out. So you're left with 20 minus x. And this 2 to the 2 don't really cancel out. It just becomes a 4, which we'll see in the next step, I'm sure. So that's another cool little thing you can do to get rid of logs is base them. Let me get rid of this. It's confusing me. That pen is very weird. So you can base them. So what we're going to do here is we're going to base them by 2, and then we get this 4 equals that, and then you can just solve this like a normal, I said equals that, 4 equals 20 minus x. Just solve this like an everyday polynomial, which again, this is frustrating me because they just switch the negative x and the 4. They're supposed to add x to both sides and subtract 4 from both sides. They're skipping a lot. Not very good when you're trying to teach. All right, guys. So the next thing we're going to do here. Oh, great. I turned off the other pen and the writing's still here. Give me a second while I get rid of this. There we go. Cool. All right. So the next thing we're going to do here is we're solving logs on both sides. So the easiest thing I recommend doing is recognizing that this adding of both logs with the same with the same base, these are both base 10, means you're going to use multiplication. You're going to multiply these two. So you distribute those out. Then what you want to do is you want to recognize that this is log base 10. So you're going to base this to both powers. So this, again, you're going to put 10 as the base on both sides. So that's how come this log just goes away. You're basing it on both sides. So this becomes 10 to the 1 power. From here, this will be 10, and you can just subtract 10 from this side and solve it like you would a quadratic. So they don't show it. I don't think Edmentum ever shows them showing their work for factoring, but they factor it out. They put the 3x squared here, a little x here, negative 10 here, and then they come up with these as the numbers that go here. They come up with this 3x minus 5 times x plus 2, and that's equal to this, so they're just substituting it in. All right. So from here, we get two answers. Now we have to account for what's viable. Now, here's the thing. Logs can't take a negative answer. So because we can't take a negative log, we can't get an answer here. So if we look here, that negative 2 can't happen because logs are never negative. If you were to graph any log, in this case, we're just going to graph log base 10. So if I grab log base 10 of x, and I zoomed out here, well, I need to zoom out or zoom in here. And I go back to 0. You see that this never touches 0. If it never touches 0, that means it's never negative. So logs are never negative. You can never have a negative argument for your log. All right, so I'm actually going to end it on that note, and then we'll do the activity in part 3. All right. So see you guys, and that should be the last one. Part 3 should be the last thing we do. All right.